Hi everyone. Today our first look at redox chemistry. A redox reaction, it's a kind of reaction characterized by a transfer of electrons. It's divided into two halves, reduction and oxidation. Reduction, R-E-D, oxidation, O-X, gives us the name redox. Because this is a transfer of electrons, there's a gain and a loss. Or reduction, it's a little bit strange. Reduction is a gain of electrons, and oxidation is a loss of electrons. We have this pretty standard mnemonic to help us remember. We say that Leo says ger. Leo, that's like a name for a lion, and lions growl. This is not how we would spell ger, but G-E-R. So this is a mnemonic to help us remember that loss of electrons is oxidation, and gain of electrons is reduction. Leo says ger. Sometimes we're going to think about the redox reaction as a whole. However, most commonly, we're going to think about it one half at a time. So we have reduction, which is half of the overall reaction. We can write those out. Here are examples of reduction half reactions. It looks just like a regular reaction. There's an arrow and states and stuff like that. But because it's reduction, it's a half reaction. We see electrons specifically written in on the left-hand side of the arrow, signifying a gain of electrons. There's two situations that are possible for reduction. A metal cation gaining electrons to turn into a metal atom. Here I have zinc 2+ ions gaining 2 electrons to become zinc solid. A second situation is a non-metal atom gaining electrons to become an anion. Here we have oxygen gas gaining 4 electrons to become oxide ions. This is a little bit fancier because of the diatomic nature of oxygen being O2. We had to balance this over here, which made us responsible for adding in 4 electrons. Half reactions themselves are balanced in 2 different ways. The chemicals balance, zinc, and the charge on opposite sides of the arrow likewise balances. Here we have a 2+ and a 2- on the left-hand side. Those cancel off. The left-hand side of this half reaction is neutral, and my zinc atom here on the right-hand side is also neutral. In this oxygen reduction half reaction, the oxygen gas is neutral, but these 4 electrons are 4-. The total of the left-hand side is 4-. Here on the right-hand side, we have 2 oxygen ions, which are 2- each, for a total of 4-. The second half of the story is oxidation. Just like we can have reduction half reactions, we'll have oxidation half reactions. There's 2 scenarios that can lead to oxidation. It's a metal atom losing electrons to become a cation, or an anion losing electrons to become non-metal atoms. Here I have aluminum solid undergoing oxidation to form aluminum ions, 3+, and it's going to lose 3 electrons. The chloride ions here lose electrons, undergo oxidation to become chlorine gas, and there's our electrons. Just like how our reduction half reactions over here were balanced in 2 different ways, where the chemicals were balanced and the charge balanced, the same thing's happening here with our oxidation half reactions. 1 aluminum, 1 aluminum. The left-hand side is neutral. We have 3+ and 3- on the right-hand side. Those cancel off to leave no charge. Here with the second example, the net charge of the left-hand side, 2 chlorines that are each 1-, is 2-. We have a neutral chlorine atom and 2 electrons, 2-. What we can do with these ideas is analyze a net ionic equation. Here I have sodium atoms that turned into sodium ions. Something that was neutral became positive. That's oxidation. We had to lose electrons. By losing negative charge, the neutral atoms became cations. By a process of elimination, then, the magnesium must have undergone reduction. But when we look closer, we see that it was 2 plus became neutral. The positive charge gained electrons, underwent reduction to become neutral. Now, here's the very tricky part. The substance that gets reduced, we call it the oxidizing agent. And the substance that is oxidized, we call the reducing agent. So it's a little bit strange. The oxidizing agent is the chemical that got reduced, and reduction is a gain of electrons. The reducing agent is the chemical that was oxidized, and oxidation is a loss of electrons. So, the sodium became positive by losing electrons. It underwent oxidation. That means it's the reducing agent, Ra for short. The magnesium was positive. It became neutral. It gained negative charge. It gained electrons. It underwent reduction. And because it underwent reduction, we call it the oxidizing agent. So, our first look at redox chemistry, the terminology is a little bit crazy. Reduction is a gain. Oxidation is a loss of electrons. An extra layer is that the substance that gains electrons, that is reduced, we call the oxidizing agent. We can think about reduction in a couple of different ways. We can think about it as individual half reactions. When we have a net ionic equation, we can analyze it in order to decide which chemical got reduced, which one is the oxidizing agent. We have all the analogous things going on with oxidation. It's a loss of electrons. We can think about it in isolation as half reactions. If we have a net ionic equation, we can analyze it in order to determine which substance was oxidized or which one was the reducing agent. And I hope that helps.